This is Eagle R1. It is Nebula Aerospace's first flight computer. It will be used to control a thrust vector control rocket, as well as log flight data. The board uses exclusively through-hole components, meaning that no chips are mounted directly onto the face of the board. The board uses an array of different sensors and chips to measure, control, and log data. When designing the board, keeping the cost low and using components that are widely used and supported were the main factors in deciding what chips to use. The main processor is a Teensy 4.0, which takes all the data from the sensors and turns it into a controlled output for the TVC mount. It has 24 GPIO pins, 22 of which are occupied. For a gyroscope and accelerometer, I went with the BNO 055. Originally, I was planning on going with the MPU 6050, but after looking into it more and getting some advice from the community, I chose a similarly priced, higher quality sensor. For a barometric pressure sensor, I chose the BMP 280. It is a very widely used sensor, and besides that, there wasn't much of a reason, just that it works for what I'm doing. The computer also has a microSD slot and a flash chip, which will allow it to store flight data, and then transfer it when the flight is complete. When the rocket is flying, it needs to be able to control in-flight events, such as lighting the engine, deploying the parachutes, and in the future, deploying things like legs, retro motors, and fins. To do this, the board has 4 pyro channels, each of which use a MOSFET and some resistors to give a stable current output, which is switched on or off by the flight computer. The current is delivered through 4 individual screw terminal blocks. For the battery, Eagle is capable of taking anywhere from 5 to 18 volts. It currently runs on a 9-volt battery, but that might be upgraded to a higher voltage LiPo in the future if there are pyro channels that need higher voltage. The battery input is a terminal block on the side of the flight computer, and positioned beside it is an arming channel, which is another terminal block. At the moment, it is being armed by a small wire that jumps across, but in the future there may be a switch added. The raw 9-volt battery signal goes only to the 4 pyro channels as well as the 5-volt voltage regulator. Some of the chips take 3.3 volts, which is taken from the Teensy's inbuilt 3.3 volt output. There is also, of course, an RGB LED on the board as well as a buzzer. These combined are used for state indication and startup confirmation. The computer will be used in the upcoming Orion rocket and possibly future projects. Thank you for watching, and I'll see you in the next one.